Here's the answer for day 2. This isotope of radium has a half-life of 1,620 years. What that means is, in 1,620 years, half of the quantity of radium will have been converted to energy. So it will lose half of its mass in this number of years, and that lost mass will be given off as radiation. If there are initially 10 grams of radium, then how many grams will remain after 1,000 years, and how many after 10,000 years? Use the formula on page 320. So that formula is Q of T equals C times E to the KT. Letter Q means quantity, so Q of T is just a way in symbols to say the quantity of the substance at a certain time, the quantity after a certain number of years have gone by. The letter C is representing the initial amount, what you have to start with. K is a constant unique to the particular substance that is decaying, and the letter T is time in years. To figure out how many grams of radium will be left after 1,000 years is a two-step process, because in step 1, we have to discover the value of K for the substance radium. So let's make substitutions into the formula. Let's do a what if. If the value of C was 2 grams, meaning if you started with 2 grams, then the future value, Q of T, would be 1 gram when 1,620 years goes by. So for letter T, fill in 1,620. Our what if did not have to involve using a 1 here and a 2 here. We could have selected any numbers in which this number is half of this number. Now let's solve this until we figure out the value of K for the substance radium. So divide both sides by 2. We have 1/2 is equal to E to the 1,620 times K power. To solve an exponential, we do a natural log. So take the natural log of the left side and the natural log of the right side. The natural log of 1/2, if you round it, is negative 0.6931. There's actually many more digits on my calculator screen. On the right side, natural log cancels E and leaves the exponent. Now to get K alone, we divide by 1,620. I've actually left this really long decimal on my screen, so I now just need to type divide 1,620 and hit enter. The result is negative 0.000427. There's actually more numbers after that, and I'll leave them on my screen, but for writing on the paper, I'm only going to write this many. Now step 2. We could answer the questions that were asked. We actually asked 2 questions. How much is left after 1,000 years and how much after 10,000? So to find Q of 1,000, we replace C with the initial amount. We're told we have 10 grams of radium. And we replace K with the value we just figured out, negative 0.000427. And then for the letter T, we replace it with 1,000 years. Type this expression into the calculator. And the result, if you round it, is 6.51. We were finding a quantity, so it's in grams. Now let's find the other quantity. What is the quantity after 10,000 years has gone by? We know we're going to get a smaller answer because with more time going by, more of the radium will be converted into energy, leaving less mass. So 10 E to the negative 0.000427 times 10,000. When typing this in the calculator, the result is 0.139 grams.